5 minutes break. And Nathaniel will join us in 5 minutes with his presentation on using LLMs for voice input.
Yes, you can.
Aris.
Aris did say I can have 5 minutes.
Okay, if he says
No, it's all right. I just need to test my sound.
That's right.
I'm not sure if it's going to work.
In the worst case scenario, first.
Yeah. We'll see. We'll see.
Worst case scenario.
Thank you.
Hmm?
How you do with
Yeah, I don't know if that will work. You need to connect to Zoom though.
Yes.
Still. Mm. He got the link.
yeah.
Thanks for checking.
Don't have in the link Matteo and Paulo.
I will sort it out. I'll sort it out. I'm sure. I'm sure. Like as long as this guy don't kick you out. Yeah. Yeah. Yeah.
Sorry. Just need to make sure. The Zoom room.
Speaker.
But it says host has joined. You let them know you're here. I tried to join Zoom. It's just someone on the. So the host needs to.
You should be in.
Yeah, I'm in now.
You can share your screen.
Bear with me a moment. Do I need to share?
You unmute yourself for sure.
Content. Or
If he was muted, it means his voice hasn't been recorded. Okay, great.
I'm going to stay muted, but I want to share desktop one and I want to share sound. Okay. I'm sorry.
I'll be showing you this marquee with how much time you left. It's not like a pressure, but
No, 100%.
if you notice, it's just blink or do something like that, and I will know that.
And then I just want to play. Give me a second.
Loved and lost and feared and prayed.
I just wanted to check that sound was working. And oh, no, I'm not ready to go. One more thing. Sorry, I'm so sorry.
Do you mind passing my bag? Thank you so much for understanding, because I will take photos.
Thank you. Make me look good. Alrighty, folks. The show is nearly ready to start again. So please find your seats and give the most mediocre clap, please, to Nathaniel. Hey folks, nice to meet you. It is always a pleasure to see some familiar faces and a bunch of new faces. So for those of you who have never seen me before, hi, nice to meet you. My name is Nathaniel Okenwa. I'm a developer evangelist at a company called Twilio. How many people in this room have heard of Twilio before? I'm doing my job well, thank you. But for those of you who don't know, Twilio is telecommunications APIs for developers. So if you ever wanted to integrate email, phone calls, SMS, WhatsApp, all of those communication channels, probably with your end users, maybe you want it for 2FA or you want to give them notifications, maybe support chats. You can build all of that using Twilio. And so I talk a lot about that and write code. And because I talk a lot and write code, my friends call me Chatterbox Coder, and that's how I'm known on pretty much all the socials. I love many things. I love coding, I love MMA, I love anime and superheroes. So if you want to talk about any of those, feel free to come and find me. But one of the things I love is movies, especially superhero movies. And one of my favorite superheroes is, you guessed it, Iron Man. Now, I love Iron Man. I can relate to him as an engineer. Like, I don't have superpowers, but being a builder is my superpower. Unfortunately, I do not touch hardware. So I can only really work with software. And one of the software that I've always dreamed of being able to build was JARVIS. And it's not just from the Iron Man movie. We've been sold the dream of these AI agents for decades. We had HAL 9000. If you like animated movies, we had Auto from Wall-E. If you like more animated movies, we had the Bat Computer. And I still think that the best one is JARVIS. Now, one thing that we see in all of these film depictions of AI agents is there is a very, very common thing. They're not accessed through text or dashboards, but they are accessed through voice. The AI agents spoke. And this wasn't just because of narrative utility. It is user choice, right? It's user experience truth. Writers chose voice because it's the clearest shortcut to believable, frictionless human AI interaction. And what do I mean by that? Well, voice by definition and spoken language by definition is the most human interface of them all. And characters never had to learn how to use these AIs. Speaking to them was as natural as speaking to another person. And another thing I find interesting about these AIs is they were always on. There was this ambient access. They were always available, responding instantly without needing a keyboard or screen. And we've been trying to recreate this with technology. Remember in 2011 when Siri came out? It was a breakthrough in mobile voice interactions, but it was limited. It only had scripted commands, it often misunderstood context, and it didn't have conversational flow. They upgraded with Alexa. Every time I practice this talk at home, I have to say the A word, otherwise my whole things go crazy. But Alexa dominated the smart home. But again, it was primarily command driven, and it lacked memory, lacked personality, and really any true contextual understanding. So these systems were good at listening, but they were not great at understanding. They were tools, not companions. They weren't Jarvis or HAL. But it was a good attempt because it paved the way for the way a lot of implementations of AI, specifically LLMs, that we are seeing today. So LLMs came along and they changed everything. We had true conversational context. So LLMs could track open-ended conversations, handling ambiguity, follow-ups, and corrections, just like a human would. And they were flexible. No rigid commands. Users can speak naturally and still be understood. Now, LLMs also have a very subtle emotional intelligence. They can pick up on tone, on phrasing, and intent, and adjust responses based on that, something old assistants couldn't do. And they also had a wide knowledge domain, so they could generalize knowledge across different domains. And they also, especially when you moved into the world of agents, they became action-oriented. They could trigger actions and call tools. So today, I want to talk about building our own voice interfaces. Now, we'll use many of the tools you'll think make sense. We need speech to text to understand what the user is saying. We need the LLMs and the tools, which is the brain, which is going to decide what to say and understand the user's context. And then we're going to do text to speech to then turn that into something a user can understand. But before I do that, I want to talk about the uncanny valley. Ooh, I should have inserted some Halloween sounds right here. What is the uncanny valley? Just a quick question. How many people have heard of uncanny valley before? All right, a bunch of you. But for those of you who don't know, it was a phenomena introduced first by Masahiro Mori, who was a robotics engineer, robotics professor. And he talked about the fact that when we see different objects, we have an emotional response to them. Now, the less human-like that object is, the less our emotional response, the strength of our emotional response. So you look at a phone, you don't really see any semblances of humanity on your phone device. It's not really that much human. But you step up to a teddy bear, cuddly, warm. Now that's more human. And even some robots are kind of cute. But then you get into this uncanny valley, even though the item's getting more and more realistic. Think of a mannequin or a zombie or one of those really, really advanced robots that look human, but there's something off about them. And now, if that is not a good example, I have a better one. If you like Star Wars, think about the Star Wars movies. When we first had the first Ewoks, right? Ewoks? Yes. They were fluffy. They were cute. Like there was something nice about them. And it was really just a man in a suit. But we all were like, oh, that's an alien right there. And then Star Wars had more CGI and we had this character. It looked terrible. And it really, really stepped into that uncanny valley, even though objectively, that was supposed to have very, very realistic light bouncing off of it. It looked worse. Now, forget about Star Wars. What does this bring to our AI conversations over voice? We want to be able to avoid the uncanny valley. Now, we're not trying to say we don't want people to realize they're talking to AIs. That's a whole ethical conversation. But what we want is for it to not to break the user experience that they are having. And so some of the things that we can do to kind of escape that uncanny valley is to focus on the conversation and the art of conversation. When you're talking with someone, you don't have a linear conversation. People interrupt, you pause mid-thought, you might change direction. So AI voice interfaces need to handle overlaps, false starts, and non-verbal gaps and interruptions. And timing is everything, because a delay that's too short can feel robotic. Like you didn't really understand exactly what I was saying. But a pause that's too long can feel broken. And the rhythm of speech is as important as the words that you are actually saying. And then there's also contextual flexibility. Now, a user might walk away mid-sentence or switch topics suddenly or give unclear input. A rigid system breaks, but flexible interfaces adapt. It should have some extra context and be able to understand what we're talking about in this context. So we're not just trying to build an AI, we're trying to build this conversational partner. And that means designing for rhythm, not just the content. All right. I've talked a lot about these problems, but instead of just telling you, I think it's good to show you. So let's run our code and start building. I actually started building already. I've got these slides right now. This is Google Slides, but I'm going to switch to a little Next app that I created. And this is also a slide controller. I can go to the next slide. I can go to the past slide. It's just a little React app that's taking images and it's taking my content downloaded as a PDF with my images and my speaker notes for the slides and just creating that. There is one little thing different in this top corner. as we all know, we are being forced as engineers to put AI into everything. So I put AI into my slideshow presentation. I have this AI assistant that I can ask to do things. So I could say, go to the next slide. And should think about it, should understand, should go to the next slide. I'm gonna go backwards one. So that's cool. But one thing that I've done next is I've actually using Twilio to handle some audio and WebRTC. I've got DeepGram to do speech to text. I've connected it to OpenAI for that LLM. And I've also got text to speech going on as well. But this time, let's take a look at some of the code that is making this happen. So what happens is, let me actually do a test run first before I do that. So I'm gonna hit the microphone, go to the previous slide.
Moving to previous slide.
All right, so you can see it can understand me, it can do the things that I've said, but let's see, oh no, like I think I've forgotten all of the details on this slide, but the great thing is my AI companion has access to my speaker notes. What was supposed to be on this slide? I've forgotten what I was supposed to say.
On the previous slide, the content covered the technical architecture of the system for the Voice Capabilities project. It included key components like Twilio WebRTC for handling audio streams, DeepGram for real-time speech-to-text transcription, OpenAI, Claude for natural language processing and response generation, 11 Lab.
All right, we can already see there's a problem, right? It was like, cool, I know exactly what Nathaniel wants me to say, and it did it, but it wasn't feeling human. It couldn't understand. So let's take our code and fix it. So remember I said I've got Twilio WebRTC sending that audio to DeepGram. DeepGram is hitting my server. Yes, this is not on the cloud and it's going to slow it down. So if there's any performance issues, blame the Wi-Fi. So it's going to come to my laptop and we've got this transcript. So whenever a transcript is ready, so whenever a piece of text has been detected, it's going to send that to my server. And I've got this process, transcript, and respond piece of code. I'm going to ask a favor from someone. Can someone come and just hold a microphone at my mouth so that I can talk while I type? Thank you. You are awesome. All right. So first thing we need to do is once we hear that someone's talking again, the first thing we're going to want to do is we're going to want to pause the audio. So every time a new transcript comes in, even if we are mid-conversation, even if the AI is saying something, I'm going to say, let's pause this audio. And my keyboard stopped working. There we go. I'm just going to pause audio right there. So the first thing I'm going to do is I'm going to pause this audio because I want it to stop talking. But this isn't really useful because even if it stops talking, it needs to then respond. And it needs context to respond. It needs to know, what is it responding to? Is it responding to what it said, what it's been halfway through? So we want to give some extra context. And the cool thing is I can actually do that on the fly. So first thing I'm going to do is I'm going to say, I want to know what is currently saying. And the cool way that I can do this, I've got a little few things, is I am keeping track of the last sentence spoken. So I have this last sentence spoken, and every time I send a new piece of text to the audio generator to generate that speech, I go, this is the last thing we said. This is the last thing we said. So I'm holding on to that each time I send some text tokens over there. And then now that I have this last sentence spoken, the next thing I want to do is I want to figure out what has the user just said. So I need to know what the interrupt is. And if the interrupt is, so the thing that I actually want to do is I want to check if we are currently saying anything. So if we're currently saying something, then the transcript is null. So I'm going to say, hold on, are we interrupting? Were we currently saying something? If we were not currently saying anything, so nothing was still playing. Does that make sense? So we've played some audio. I say, wait, is audio still playing? If it is, then we are interrupting. If there is no audio interrupt playing, it is not an interrupt. Make sense? And so now I've got some extra things in this process transcript and respond. First, it takes a WebSocket just to know where to send the response to, but it also sends a transcript, which is what the user said. But I'm going to also add the interrupt and the currently saying. So saying there was an interrupt, so this will be true. And here is what the user has just said. Here is what you were currently saying that the user has interrupted. All right, let me double check. I can see a error code, and I think it's because I haven't closed that. Perfect. And let's try this out and see if that works. Let's go back. Hey, what's on this slide?
This slide covers the technical architecture of the system for the project. It includes the tools and components involved in the voice processing system. Twilio WebRTC manages phone call audio streams. Deepgram provides real-time speech-to-text transcript. Twilio WebRTC is a technology that stands
You see
for
that, right?
real-time
So
communication.
what did we see there? We see it stopped, but then it didn't just stop and then create a whole new generation from scratch. It stopped. It said, Nathaniel interrupted me right when I just finished talking about Twilio WebRTC. And then it now generates a response to that very, very specific bit. And so now we're adding this interconversational response where as the AI, as the LLM is going on, we're giving it the tools to be able to reply on the fly in a conversational tone. Voila! One step down, a couple more to go. I should minimize this. One step down, a couple more to go, even though I'm running out of time. The next one I want to talk about is voice interstitials. Now, moving to a next slide, moving back, it's really easy. It's pretty quick. It's just like a simple call that's going to happen. But oftentimes we may want to generate things or we may need to search the web. We're going to need to do things that are going to take a little bit more time. Now, these tools are really, really good, but they also, no matter how fast the internet is, they're going to take a couple of seconds. And that seconds can break the feeling of a conversational flow. And so what a lot of these tools do, these AI voice agents do, is they use voice interstitials. So this is where you have some preloaded, even pre-generated sounds like, let me think about that. Or I'm doing the task that you say. And so then what you can do is you can have very, very quick interstitials that get played out to the user so that they understand that the AI agent is still doing something. So remember, every time I sent a message, let's just say hello, you see there is that little AI is thinking, and it gives me notice that the AI is going to come back and do something. Well, what we can do is we can do something similar. I am running out of time, so I'm going to blast through this. Can we get a microphone holder again? Sorry. You're on double duty today. Okay, so the way we can do this is we can actually, you can do this in a couple of ways. So first of all, when you are given an AI agent different tools, you're going to know which tools are going to take a while. Maybe they're searching the web, or you just don't know how much time they're going to take. And what you can do is you can have a very, very lightweight, very, very fast model that can just decide, should I play a voice interstitial or should I not? So it's something very, very lightweight, trained specifically to look out for certain tasks. And that's what I have. I have a model that just checks to say, is Nathaniel going to try and generate a new slide? Because generating an image takes time. So what this is going to do is I have a voice check that is happening up above called this should play voice interstitial. And let me scroll back down. And so what I'm just going to go is I'm going to say if voice check should play. So I'm just going to say if we should play this interstitial that we checked for. So what this is doing is it's actually listing out for the different tools that are called. And once a tool is called that is going to take time, in this case it's image generation, it's going to play this voice interstitial, and then I'm not going to bother resetting the flag because that happens somewhere else. So that's what I'm doing. I am then checking to see if this interstitial should play, and then I can play it. And what does that look like in practice? Hey, can you generate a new slide to tell my audience that they are awesome? Oh, I've broken something. Oh no. Okay, I am running out of time, so I'm just gonna pause it right here and continue on. So what actually happens here is that I have a lightweight model that's just trained specifically to look out for, are we generating a new image? And if it does, I don't want to log into my work bits, not right now. Not right. I don't know what's trying to get out the way. Cancel. Okay, and sorry about that. Okay, so it's going to play some voice interstitials to filling that silence. And we actually interact with this. If you've ever used Gemini Live, if you've used Gemini Live or used ChatGPT voice mode where you talk to it, you'll notice it often says, or let me think about that. And that's because let me think about that means if it's called in a tool, instantly it's going to play that. They have a bunch of different ones and it selects them at random to make it feel human. All right, the last one that I wanted to talk about was contextual flexibility. And this actually, it's been built in all the time. Every single time that I was changing a slide, every single time I was moving forward, I was given new context into my LLM so that it knows where the current status of the slides are, where the current status of the speaker notes were. And what you can then do is you can implement other events to trigger your LLM to generate things and then to say text. And what that really allows you to do is have situations where you give an AI agent, the ability to decide, I am going to come and take initiative and tell my user that something has happened. And then this is really powerful because it then gives you the ability to take an AI agent from something that you're continually asking questions and telling it to do stuff to giving it the initiative to come and hit you first. So you can have event triggers that trigger your LLM and then still have that output outside. All right, I'm going to switch back to my slides and wrap up really quickly because I can see people sweating in the back. Let's move on. All right. So now, how many people have heard of speech-to-speech models? All right, yeah, and you may be going, cool, Nathaniel, you did speech-to-text, you did a bunch of stuff, but won't speech-to-speech models make all of these obsolete? And that is an excellent question. But this voice stack of going speech to text and then playing around with this and making it still feel natural is important because it gives you control and transparency. There are only 2 publicly available speech models that you can use, and they are black box. You can't put guardrails, you can't give it context, you can't do any of these other things. And then you also end up with much more vendor lock-in if you go down that route. Also, this allows you to have a composable architecture, so you can use a couple of different things. And today, LLMs still work better over text. I've put slash today, and every time I give this talk, I'm going to do that. And it's also ready to use today. At Twilio, we've actually been doing a lot of this stuff with customers where people are building AI agents that can talk, can book appointments, and can do all of these things. But then they're not only just doing it for inbound, they're also doing outbound calls where an AI agent is deciding to call a customer and then give them some communication. So we've done these 3 things and it's been absolutely fabulous. I work at Twilio, and why am I talking about this? Well, conversational AI has so many different things, and we have a couple of different products. But one that I want to talk about is Conversation Relay. I gave you a whole talk about how you can build that natural sounding voice, but we at Twilio actually decided to just put it in a box and give it to you as an API where we shoot text tokens at you and you shoot text tokens at us. We will shoot an interrupt token at you to say the user's interrupted and they interrupted when you were saying this. And in that way, if you have no idea about voice technology, you have no idea how to build all of that super fast, you can just do that with Twilio. I don't want to go into it, but if you want to ask me more about that, feel free. It's a bit like JARVIS, but with more me. All right. That's enough of me talking for today. Thank you so much. And my last words to say, I am out.